In your learning goals for this unit, the second one says that you can identify the signs of displacement, velocity, and acceleration from motion diagrams. Well, I'm going to show you what motion diagrams look like. They're very easy way to think about them would be like using the frame-by-frame advance on your DVD player. Let's say you're watching a movie and you pause it. Usually if you hit the pause button again and again and again, the movie will move forward one frame at a time. Hence the term frame-by-frame advance. And of course the idea is that each frame advance is an equal time interval. Well, that idea is very powerful when it comes to teaching and understanding motion. So imagine an object is moving and you've videotaped it, and then you kind of go back and watch it frame by frame. And how much motion happens during each equal time interval can give you an idea of what's going on. So in this particular simulation, I've got three objects, three circular objects, and the first one says it's constant velocity, the second one says positive velocity and positive acceleration, and the third one is positive velocity and negative acceleration. I want you to try to remember what we talked about. What does it mean when the signs are the same for velocity and acceleration, and what does it mean when the signs are opposite? So I'm going to press this run button and they will take off. Alright, well, what this program did is it tracked the motion, and every once in a while it left an image of where the object was. And so here we see that the spacing between the objects are all identical, and that's what constant velocity means. Equal distance covered in equal time intervals. Here, the spacing between the objects in each time interval is increasing. The object is obviously getting faster, and so let's just say, for example, that each dot represents 1 second of elapsed time. Well, in each second, the object has traveled further. Obviously, it must be going faster, and that's exactly what we expect. When the signs are the same, we said an object speeds up. Down here, the object was moving forward, which is a positive velocity, but in the time interval, the spacing is decreasing, hence negative acceleration. Acceleration is actually pointed the other way. Another example would be a free fall example. And so here I have an object, and when I press run, it's just going to fall. So let's watch that. And we're not surprised by this. We noticed that because of the force of gravity, the object picks up speed on the way down. So the sign with the velocity would be negative, and the sign of the acceleration would be negative. A good reminder that negative acceleration does not always mean slowing down. It always has to do with the relationship between the signs of the velocity and acceleration.